Welcome to another test and teardown video. If I didn't say this before, I really would like to say this again. I just love HP. It's just so beautiful. So this is an HP 410C voltmeter, but it's not just a voltmeter. It will do DC volt and AC volt, and also it will do microamps and milliamps. AC probe, jack connector, on-off switch, and a beautiful analog meter. I don't know exactly if I love or hate this. Why couldn't it just be 3 banana plugs? Because see, this one is old and crusty, and they're shielded cables, and in the other end they're also a little bit, what do you know, crusty. So this we need to fix. I was poking a little bit around with this is the DC volt, and then the wire fell out of the, I don't know, would you call this a probe of some sort? The wire is held with these two halves. They kind of grab the wire from two sides, and then this one is screwed here, so it presses the wire, and it kind of just fell out. And then I thought, that was odd. And what is the whole idea about this? So I took a piece of wire like this and stuck it in, and what do you know? There's a 1 mega ohm resistor in here. Ain't that funny? And then of course when you break the tip, the idea is you put in a new little needle tip, and then you can screw the needle tip, and then you can, you know, go and grab points and test. And so that's fantastic. I don't have this top screw here, so that is missing, but other than that, I think I got all the parts to restore this again. So this I will save for later. I just measured ohms on this one, and it's actually connected here where it's super crusty, but it's up here. When I move this, I lose the connection. So that means we can't really test a lot of stuff before we kind of fix stuff. And I am lucky to also have the AC probe. And that one just connects here, and then it probes AC signals and stuff like that. So let's power it up and see if there's any smoke in this bandit. One more thing before we plug it in. Yes, voltage selector is correct, 230. Okay. So it just went on when I plugged it in, so that was disappointing. Nothing much to see or hear. It seems like it is alive. It's got its kind of own life. See? And then it just goes, ooh. So definitely. So that is DC amps. I don't know. Well, something is alive. There's no smoke, there's no kaboom. But I will of course see if I can restore the cables and input something, and then we'll see what happens. We need to test a little bit before we open. That's how it works. What do you know? So this is about 1 volt, and I am in with the cursor for 1 volt change step. And what do you know? I rotate it. Oh, it is super critical about the dial here. So there's definitely a lot of loose connections. But this is 1 volt input, and now 2, 3, 4, and 5. Let's go back to 1 again. And as you know, this is negative because I swapped the input just to test the negative. So let's take this off and go to positive. See how this is a little bit crabbity, right? So let's grab the input here. And now we're in positive. 1 and 2, 3, 4, and 5. Let's go back to 3. Let's get some light here. And let's see. I can make it read kind of whatever I like just by moving it a little bit. So this needs a little bit of cleaning, but other than that, I guess we are ready to rock and roll. So it's not completely dead. It is possible to fix. So that was DC volts. Let me test a little bit of DC amps as well. So now I just put 3 volts, but in series with a 1K resistor into the red wire, and that says DC amps and ohms, of course, and that is to common, and then the common is back to the supply. All right, so that means whatever voltage I got on the supply, that will be the same milliamp it should read, right? DC amps, 5 milliamps full range. 5, is it that one, right? Volts and amps, so it's this. So it's reading a little bit too much, 3 point something. Okay, let's go for 4 volts. Okay, and let's go back to 2, 1. How about if I turn this off? It goes to 0. And back to 1. All right, so this thing can actually read volts and amps, probably also negative. Should test that as well. Okay, let's try ohms. So resistance times 1K, so that means 1 here is 1K, right? Ooh, it is a little bit sensitive for touching. And again, I got my 1K resistor, and then here's my ground wire. Let me poke that on. Oops, here we go. And it shows a little bit too little, but also this is not correct either. So that could explain why it's not super accurate. Let's try that times 10. So any guesses where it's gonna go? Yips. 0.1 times 10, that is 1K. Yay! So I actually think the only problem with this one is the really crusty switches here. I need to fix this. And then AC volts, that means I need to try the probe. Hey, let's try the probe. That is right here, right? Oh, it's... What is that? Okay, I need to plug it in. Can I plug it in when it's turned on? Or should I turn it off? And why can't we see the... Why haven't we got any light? Ooh, you need to touch this to get it. Oh, okay, that's also a little... Oh, this is full of little funny things. So if I turn it off, then go to AC volts, stick in my super sexy probe. Oh, that was actually easier than expected. All I did is 1 kilohertz and 5 volt RMS. And what do you know? AC volt and 5 volt full scale, right? So this is 5 and 4, 3, 2 and 1. Okay, so it definitely need a lot of, and then off. Oh, and it goes a little bit too low. And there's a little bit of funny thing here. I can make it go a lot too low, but not quite as high as I need. So my guess is the voltage supplies, one of them is a little bit off, right? Because that can explain the little bit off thingy. Then we got this mechanical thing. But I think it is time for teardown. But before we open the main unit, of course we're gonna have a look at this super duper sexy probe, huh? But where's the capacitor? So there will be a capacitor in here, right? Let's try and see where it is. Normally you'll find them all the way up here. Yeah, yep. This thing can actually measure capacity, but not that. Okay, like 2 or 3 nano. Fantastic. So there's a capacitor in here. And what do you know? This is the okay, here we go. Okay, so this is just the boring. So this is everything is just in one goobity. No, oi, oi, oi. What is that funky connector? And what is in there? Is this really just the connector to? Ooh, look at that. We got 3. So this is no, this is the chassis. So there's another connector, and then there's another one again. So we got 3. Okay, this explains why we got 3 here, right? So that means there's some funny thing in here that needs 3. So I need to find a screwdriver. And then what? But I can definitely see some funky stuff in there. But I really don't want to break it. So, okay, it goes that way. Really? Yeah, okay, you can actually see this tube goes in like that, right? So, wow. Oi, 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 what is? Can you see that? I got some text and stuff on this baby. So you know what? There's a little amplifier, a tube, or some funny. I guess you're not supposed to pull this further apart because you can't really. Yeah, you can turn this. Okay, so this is. It actually turns. And. Oi! There is actually another connector. Because look, there's a little plastic isolation here between the inside and the outside here. There's also isolation. And then there's this metal here, and then I'm getting a little bit confused because this, I can turn this around. So what is in there? And yeah, that was exactly what was happening. This thing is changeable. So we got some little springy contacts here, that kind of grabs this. And here is some I don't know exactly what I would call this. Some springy stuff. And this goes inside the probe tip. Oi, 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 oi. Velvy, we got a tube. Velvy EA53. That is some sexy tube. Wow. I think we should consult the manual. And now it is back assembled. Here we go. So I guess this is the number 1103 6A AC probe, yada yada yada, HP fantastic thingy. And of course you need to add proper grounding here. So this is a banana plug. That's what I would expect. Yeah, sure is. Alright, that is nice. Let's look inside the menu. So that was almost too easy. Just one screw and we're in. And as far as I can see, this must be the chopper thingy, because this one is a chopper amplifier. It is made of neon bulbs and some photosensitive resistors, probably LDR kind of types, and that will be inside this super nice unit. It is really, really cute. I think let's try and power this up again. Yes, that is exactly what I wanted to see. See down here, we got the neon bulbs, blinkety blinkety. Let me see if I can make a high-speed video of this. There is actually a long time between I find something really, really bad in HP products. But look at those resistors. They got some nasty marks on them. And this is because of this back plate, or the bottom plate here is just so close to the resistors, and it's very thin and flexible. You can even see that it's bended in. Ooh, it's really, really like this. Ooh. So that means it's really, really easy to damage the resistors here because they're just too close. But look at this beautiful product. Wow, it's full of wires and stuff. Got some diodes and the capacitors and all that stuff. Of course, all the resistors for all the different ranges. A little bit of calibration. But I must say, it's really, really beautiful. It looks a lot like all the other HP products, where you see all the main metal frames here. They are reused in a lot of other products. And as far as I can see, we should be able to pull this up. Right? Is it Is it screwed in place somewhere? Here is the PCB. It was actually possible to pull it up, but it was really stuck. And I did consult the schematics a little bit. And look at those 4 blue wires. And then again 4 blue wires in each of these rooms. And they're connected to a single center point. So that will be the photoresistors. That's in here. And the other photoresistors. So you got 4 photoresistors 2 and 2 working in alternating mode for the chopper. Of course, on the input, and the output is in synchronous operation, of course. And the neon bulbs, they're sitting inside, including the resistors and capacitors for the timing. And you see those are, of course, the black and the red wire for that, because here you got the 47 ohm to ground, and then the other one is the positive that goes via this trimmer for the oscillation frequency to the plus 270 volt DC rail. So that is what this fantastic thing does. And then we got the amplification and the transistors for that. Really, really beautiful unit. And those capacitors, look at that. Beautiful. This one is sticky when you, this is super gross when you touch this plastic. Let's look at the tube here. Nicely shielded. 1287 dual triode. Tiny little tube. Actually a little bit fun to see this and the schematic at the same time. So this is R1 and the 2 diodes for input voltage limitation. See this point here goes to the capacitors, and then it goes into the first photocoupler. Right. So the center point of that one, is it that side or is it that side? I'm a little bit curious about. Then it goes to, I'm looking for this 57 mega ohm or 56 mega ohm. Where is the heck is that? Is that this resistor that is here? On that point here, is that the red one? How about we just measure that? Aha, I found it. And look at that. I'm actually able to measure that kind of resistance. That is crazy. So this is the input to the tube. 56 mega ohm. 10%. Right. That is why you're using tubes, because then you can do crazy stuff like that. But everything here is just super low leakage, plus of this and that and whatnot. Look at those capacitors. They are really special. Yeah, that is something. And that is kind of what this is, basically. Yeah, we got all those fancy-pantsy resistors down there. And they're just 1%. And there's like 0.5% as well. Oh, nice. That must have been a little bit expensive in 1962. Up in the top, there was another PCB with all their adjustments. And of course I can poke around with this because this definitely needed calibration anyway. But don't you just love it? It's just made so beautiful. And again, the metal can is the kind of stuff that where you touch with your screwdriver, right? So those are of course connected to ground. So they're not live. It will pick up all sorts of stuff, right? Or they go all through a 1K. Yeah, that's actually a little bit funny. They all connected together, and then maybe this is just me that is misunderstanding this. But anyway, beautiful, beautiful. A little close up on the cable entry. So the two signal cables, they are definitely shielded. And the ground one is not. So it's connecting the two shields to that point. And then the two signal cables, they go in here and here. So it should be fairly easy to change the cables. Or even better, change it to BNC or something, so you could easily swap this to something else. That is definitely what I would have done. Just change this. There are actually plenty of space for a BNC here. But these are actually quite alright. I think I'll see if I can get this crusty, if I can get this loose somehow, and change this cable. Yep, that was actually quite easy. Just push this release and pull it out. So just cut the wire here so I can easily see where to mount it. So that was actually easy. This thing is really meant to be serviced and repaired. So you can change those cables just as easy as pushing out those things and just solder it all in again. So that was, I'm really happy about that. Now I just need to fix the other end. And that is it. I removed the foot here so I could get easier access. And all you have to do is push the little release and then you can pull it out the hole. This is actually also what I wanted to show, because there was a loose connection here in the cable. I thought the cable has been bent a million times, so it was broken. But this is a super high quality cable, and it's just not gonna happen. I heated it up a little bit so I could pull off the black plastic thing. But look, here is exactly where the problem is. So there's no soldering here, it's just press fit. So there's a press thing around the cable. But look at this. I don't know if it is this visible? But the inside part can move. And that was exactly why. You can hear it. Loose connections and bad stuff, yeah. This is not how you do that, is it? So let's see how long this is gonna hold. So here's what I do. the cable is held by all this metal all the way, and then I solder it here. Now there isn't any way, can't get loose. No. It is restored, so it looks a lot like the original, right? And of course I'm also going to restore the voltmeter input, and that was the broken 1 meg resistor, and then everybody's gonna be happy. You gotta believe it, man. There's a hole in this thing, and the wire is supposed to go through this hole, so you need to put this on the wire before you do the soldering. You can't be that stupid, can you? So after cleaning all the contacts and fixing all the wires and cleaning up here and fixing all this, I am assembling everything and now ready to do calibrations. But first I wanted to check if anything was any better or any worse, or where are we. So I just adjusted the power supply for 2 volts. We are in DC volt, 5 volt full scale. Alright, let's just try and plug in 2 volts and see if we need to calibrate this thing. Huh? That's pretty cool, huh? So that was 2 volts. Let's go to volts like that, and then 3, 4, 5. I mean, I am very happy about this. Let's go back to 2, and let's try and play a little bit with this one. See what a little bit of cleaning can do. Isn't that just amazing? Ha ha. All the problems are gone. It's magic.